Welcome to the deep dive. We often talk about the really famous dinosaurs, your T-Rexes, your Triceratops. Well,
Icons, the celebrities, yeah.
exactly. But today we're heading off the beaten path a bit. We're digging deep into a really fascinating, but maybe not quite household name, sauropod, a giant with a bit of a surprising backstory.
In a, well, let's say complicated family situation.
Yeah.
We've been looking through the original scientific papers, the discovery reports, the analyses that followed.
Right.
And our mission really is to unpack what makes this dinosaur distinct.
Mm-hmm.
Where did it live? When? And maybe most intriguingly, why its spot on the family tree has been debated so much.
Yeah, and that debate is interesting. Plus, the place they found it wasn't exactly known for, well, complete skeletons, was it? More like eggs?
Precisely. Known for eggs, not so much for the dinosaurs that laid them. It definitely adds to the story.
Okay, let's dive in. What is this mystery dinosaur called?
We are talking about Baotianmansaurus henanensis.
Baotianmansaurus henanensis. Okay, it's a mouthful, but it sounds impressive. What's the meaning behind that name?
Well, the first part, Baotianmansaurus, that refers directly to the Baotianman National Nature Reserve. That's where the fossils turned up.
Yeah.
And, Baotianmansaurus just means lizard.
Yeah.
Second part, henanensis, tells you the region Henan province in China.
Got it. So basically, the Baotianman lizard from Henan makes sense.
Pretty descriptive, yeah.
And who gets the credit for putting that name on the map? Who described it?
That was back in April 2009. It was a team effort, quite a few researchers involved. Zheng Zingliao, Lu Junchang, Zhu Li, Li Jinhua, a whole group, really.
A big team.
Yeah, from several key Chinese institutions, like the Henan Geological Museum, the Chinese Academy of Geological Sciences, Lanzhou University, too. Collaboration is pretty common for these finds.
Right. And you mentioned the location, the Baotianman National Nature Reserve. Tell us a bit more about that spot. Why is it significant, especially geologically?
Okay, so the fossils came from near Naixiang, which is close to Nanyang City in Henan Province. And crucially, the rocks there are part of what's called the Gaogu Formation.
Gaogu Formation, okay.
And this formation is, well, it's famous in paleontological circles, but mainly for yielding tons of fossilized eggs. Dinosaur eggs, other ancient animal eggs, loads of them.
But not so many actual bones.
Exactly. Body fossils, like skeletons or even partial skeletons, are actually quite rare there.
Yeah,
So finding sauropod bones was pretty significant, a big deal for the researchers.
I bet. And there's one specific set of bones that acts as the official reference for the species, the type specimen.
Yes, that's what we call the holotype. Its designation is 41HII-DOCO200. And if you wanted to see it, it's housed at the Henan Geological Museum over in Zhengzhou.
Okay, great. So we know the name, who named it, where it was found. Let's put it in time. When was Baotianmansaurus walking the Earth?
It lived during the late Cretaceous period, so toward the end of the age of dinosaurs.
Late Cretaceous. And what about size? Are we talking one of those truly enormous, earth-shaking sauropods?
Well, it was definitely big. By our standards, huge. But maybe medium-sized for a sauropod. So very large, but perhaps not quite in the same league as the absolute titans, like Argentinosaurus or Patagonicon, that lived around the same time or earlier.
Okay, medium-large then. Still massive.
Absolutely. And interestingly, the original paper, the one from 2009, they didn't actually put a number on its size, no initial estimate.
Huh, that's unusual. Did other scientists try to figure it out later?
Oh, yeah. Later researchers crunched the numbers based on the bones they did have. Ruben Molina Perez and Azier Laramendi, for instance, they estimated around 22.5 meters long. That's, about 74 feet?
74 feet long, wow.
And about 5.3 meters or 17 feet tall at the shoulder. Gregory S. Paul, another well-known researcher, suggested maybe a bit smaller, around 20 meters, so 66 feet. And weighing maybe 15 metric tons.
15 tons, still a seriously hefty animal, like a couple of big elephants.
Definitely. Not something you'd want stepping on your foot.
No kidding.
Yeah.
Now, you mentioned the holotype. The main specimen wasn't complete. What bones did they actually find? What are we working with here?
Right. It's quite fragmentary. They found, an incomplete vertebra from the upper back, one from the lower back, 5 ribs, parts of 2 sacral vertebrae, those are the ones fused to the hips,
Okay.
a piece of a tail vertebra, the bottom end of a shoulder blade, the scapula, and then, several other bits and pieces that were harder to place precisely.
So not a whole lot to go on, really. How can scientists be sure it's a whole new type of dinosaur based on just those fragments?
That's a great question. It comes down to finding unique features, what paleontologists call autapomorphies. These are distinctive anatomical traits in the bones that you just don't see in other known dinosaurs.
Autapomorphies, got it.
Yeah, even if the skeleton is incomplete, If you find a few really clear, unique characteristics on the bones you do have, that can be enough to say, okay, this is something new.
All right, this is the cool part. What were those unique features for Baotianmansaurus? What made it stand out?
Well, there were several. One was the internal bone structure of the back vertebrae. They were described as having a sort of spongy or porous texture.
Spongy bones. Interesting.
Yeah. Also, the neural spines, those bony projections that stick up from the top of the vertebrae. In the middle part of the back, they were unusually short on this dinosaur.
Okay, short spines. What else?
It had a really complex and well-developed system of bony ridges on the vertebrae. We call these laminae. The specific pattern was unique.
Laminae, like structural supports.
Kind of, yeah. Bony struts and plates. And another thing, its ribs. Unlike many sauropods that had air pockets inside their ribs to save weight, the ribs of Baotianmansaurus seem to have been solid. We call that apneumatic.
Solid ribs. Huh.
And then there were the tail vertebrae, the caudals. They were concave on both ends, front and back, which we could call amphicoelous. And they were also distinctly shorter than they were wide. Plus some other, even more technical details about how those laminae were arranged.
Wow, okay. Spongy vertebrae, short spines, complex ridges, solid ribs, specific tail shape. That's actually quite a list of peculiarities from just those few bones.
Exactly. Enough for the researchers to be confident they had a new genus and species on their hands.
So with all these unique identifiers, figuring out its closest relatives on the sauropod family tree should have been pretty straightforward then, right? Just compare these features.
If only it were that simple. This is where the puzzle really begins. The original describers, Zhang and the team in 2009, they were actually quite cautious.
Okay.
They placed it within the broader group Titanosauriforms that includes the big titanosaurs and their relatives, but they weren't sure exactly where. They noted it had one feature in common with a subgroup called Somphospondyli, but they felt it wasn't quite enough evidence to firmly place it within Somphospondyli, so kind of indeterminate.
So sort of floating in this big group, but not clearly anchored.
Pretty much. And that uncertainty kind of opened the floodgates for other interpretations as more people studied the fossils and ran their own analyses.
Right, because science builds on previous work, so different teams came up with different ideas.
Oh, absolutely. It's been placed all over the place, relatively speaking. For instance, Philip Mannion and colleagues, back in 2013, they looked at it and thought, this looks like a member of Saltosauridae. That's a family of titanosaurs. They even suggested it was closely related to another sauropod called Opisthecoelacaudia.
Okay, so one possibility. A saltosaurid titanosaur.
Then a few years later, 2017, Alexander Varianov and Hans-Dieter Suess came along. Their analysis suggested, yes, it's a titanosaur, but maybe a more primitive one, sitting outside a major titanosaur group called Lithostrotia.
So still a titanosaur, but maybe a slightly different branch?
Exactly. But wait, there's more. An earlier study, around 2011 by Michael Diemek, had actually suggested it might belong to a completely different, more basal group of sauropods called Euolopodidae, which would make it not a titanosaur at all, really.
Whoa, okay, so a titanosaur, maybe a primitive titanosaur, maybe not even a titanosaur. That's quite a range.
It is. And then another study by Mannion's group in 2019, this time looking at sauropods from Africa, suggested a close link between Baotianmansaurus, another Chinese sauropod called Dongyangosaurus, and a group called Diamantinosauria, known mainly from Australia.
Dongyangosaurus, I feel like we should remember that name. It seems to be popping up now.
Yes, hold that thought, because that connection with Dongyangosaurus has actually been supported by several different analyses since then. It keeps appearing as a potential close relative.
Interesting. Like maybe they're cousins.
That's the idea some research points towards. For example, in 2020, Avarianov and Lopatin proposed that Baotianmansaurus, Dongyangosaurus, and another Chinese sauropod, Yangshanosaurus, formed a distinct little group, a clade, right at the base of the Titanosauria family tree.
Okay, so multiple studies are converging on this Dongyangosaurus link.
It seems to be a recurring theme, yeah. But even very recently, like 2023, 2024, we're still seeing slightly different placements. One analysis suggested it wasn't a titanosaur, but a non-titanosaur Somphospondylian, maybe close to Wangetaton. Another put it back as a basal titanosaur, but related to things like Andosaurus or Abderaneurus.
Gosh, it really is all over the map. It feels like every few years there's a new hypothesis. Why is it so difficult to pin down where Baotianmansaurus belongs?
The core problem, really, is the nature of the fossil record for many of these titanosaurs and their relatives. We often only have fragments, like Baotianmansaurus itself.
Right, the incomplete skeleton.
Exactly. When you're comparing features across dozens of dinosaurs, many of which are also known from incomplete remains, It gets really tricky. Different analytical methods might weigh certain features differently, or new discoveries can completely change the picture. It's like trying to build a huge, complex family tree when you only have blurry photos of a few distant cousins.
That's a great analogy. You're missing too many connecting pieces. So with all this back and forth, what's the sort of current consensus? Or is there even one?
Well, the general agreement seems to be that Baotianmansaurus belongs somewhere within that big group. Somphospondylian, the one the original describers were hesitant about.
Yeah.
So it's definitely in that broader lineage that includes titanosaurs.
Okay, so it's a Somphospondylian. That's something.
It is, but its exact spot within that group, still very much up for debate. However, that repeated signal of a close relationship with Dinosaurus, that's probably the strongest, most consistent hint we have right now about its closest kin.
Right. That link seems pretty persistent across different studies. So let's pull back a bit. We have this medium-large sauropod, Baotianmansaurus, living in late Cretaceous China. Found in an area famous for eggs, it has these specific, unique bone features.
The spongy vertebrae, short spines, solid ribs.
Yeah. But its precise family connections are still being figured out, though Dinosaurus looks like a key relative. Why is understanding this one dinosaur, with its complicated story, important? What does it tell us?
Well, a few things. Firstly, it lived in the late Cretaceous, not long, geologically speaking, before the big asteroid impact. So every discovery like this adds a piece to the puzzle of what dinosaur ecosystems look like right before that major extinction event, especially in Asia, which has a rich late Cretaceous record.
Okay, understanding that final chapter.
Exactly. And secondly, the whole debate around its classification. It's actually a fantastic illustration for you of how science works. It's messy. Our understanding evolves, new fossils are found, new ways to analyze the data are developed, and scientists constantly challenge and refine previous ideas.
It shows the process isn't static.
Not at all. The fact that we don't have a final definitive answer for Baotianmansaurus after more than a decade highlights the complexity of reconstructing evolutionary history from incomplete data. It underscores that paleontology is an active, ongoing field of research. That connection to Dinosaurus, if it holds up, could tell us about biogeography too, how these animals were related across different parts of Asia.
So recapping our deep dive today, Baotianmansaurus henanensis. It's a sauropod from late Cretaceous China, named for its discovery location in the Baotianman Reserve.
A medium-sized one with some really distinct skeletal features.
Right. And while its exact spot on the family tree is still a work in progress, that link to Dinosaurus seems increasingly solid.
Yeah, that's a key takeaway.
So, even though we don't have all the neat answers tied up with a bow, digging into this specific dinosaur really shows you the scientific process in action. You can see how just a few fossil bones can kick off years of research, debate, and discovery, constantly tweaking how we see the prehistoric world.
Absolutely, it's a dynamic field.
And it makes you wonder, doesn't it? Considering how vast the time periods were and how diverse the environments these giants lived in, what other unexpected connections, what other evolutionary twists and turns are still out there buried, just waiting for us to find them?